Hey, future pilots, welcome to this exam prep explainer. We know you've got a mountain of material to cover for your ground exam, so we're going to skip the fluff and get you exactly what you need to ace the math behind turning your aircraft. Today, we're breaking down the precise formulas and concepts those examiners really want you to know. All right, let's just quickly breeze through today's syllabus. We're covering rate of turn basics, decoding the ROT formula, airspeed versus bank angle, understanding turn radius, the radius formulas, and we'll wrap it all up with a ground exam final review. Section 1. Rate of turn basics, heading change math. We'll start by pinning down exactly what's happening when your aircraft changes heading. So, the absolutely crucial point here is that rate of turn is simply measuring how fast your nose is sweeping across the horizon. And we always express this in degrees per second. Now, this isn't about the physical space your plane is taking up in the sky. Not yet, anyway. It is purely about the speed of your heading change. If you're ripping across that compass dial quickly, you get a high rate of turn. Section 2. Decoding the ROT formula, the math behind turning. Let's see how this builds into the very first major mathematical concept you're going to need to memorize. This formula right here shows us that your rate of turn relies entirely on just two specific variables, your true airspeed in knots and your bank angle. To find your rate of turn, you just take 1091, multiply it by the tangent of your bank angle, and then divide that entire product by your true airspeed. Seriously, burn this constant number, 1091, into your memory right now. It is literally the key to unlocking the ROT formula on your exam. If you forget this constant on test day, you're going to be stuck. So let's actually put that formula to the test and see how airspeed impacts your turn. Imagine you have a true airspeed of 120 knots with a 30-degree bank. Your rate of turn comes out to 5.25 degrees per second. That means it takes about 68.6 seconds to complete a full 360-degree circle. But what happens if you double your airspeed to 240 knots while holding that exact same 30-degree bank angle? Well, your rate of turn is effectively cut in half, dropping to 2.62 degrees per second. And because of that, it takes twice as long, 137 seconds, to complete that exact same 360-degree circle. Section 3. Airspeed versus bank angle. Cause and effect. Now, let's isolate these variables, because ground exams absolutely love testing these relationships. Notice the exact dynamic you're going to be quizzed on. First, if you speed up but refuse to change your bank angle, your rate of turn decreases. You're moving faster forward, so you actually carve through the degrees of the compass much slower. Conversely, if you hold your airspeed perfectly steady but roll into a steeper bank angle, your rate of turn increases. You'll whip around that compass dial much, much faster. So what happens if you actually want to keep the exact same rate of turn, but you need to change your speed? Let's say you want to maintain that 5.25 degree per second turn rate. At 120 knots, you only need a 30-degree bank. But when you speed up to 240 knots, you have to aggressively increase your bank angle to 49 degrees just to achieve that identical rate of turn. Bottom line, increased speed demands increased bank to keep your ROT constant. Section 4. Understanding turn radius, size of your turn. Let's transition from how fast you're turning to how much physical space that turn actually eats up in the sky. Now, you might be asking yourself, why do I even care about degrees per second? Well, once you understand your ROT, you can determine the actual physical distance required to complete that maneuver. Think of the radius of turn, or simply R, as the actual size of the circle you are carving through the air. We aren't talking about compass degrees anymore. This is all about feet and nautical miles. And here is the golden rule for radius. If your bank angle is held constant, a higher airspeed forces your aircraft to travel through a much longer arc. You're covering way more ground simply because you're flying faster while maintaining the same angle of bank, and that results in a much wider, larger turning radius. Section 5. The radius formulas. Calculating distance. Let's dive into the two mathematical ways you can actually calculate this distance for your exam. This first formula is the most direct route. It uses your velocity squared, meaning your true airspeed multiplied by itself, and then divided by another magic constant, 11.26, which is then multiplied by the tangent of your bank angle. Just like that 1091 we saw earlier, you absolutely must remember 11.26 for the radius formula. Let's run those numbers. At 120 knots with a 30-degree bank, your turn radius is 2,215 feet. But watch what happens when we double the speed to 240 knots, keeping that exact same 30-degree bank. Because velocity is squared in our formula, doubling the speed doesn't just double the radius, it squares the multiplier. When your speed goes from 120 to 240 knots, the turn radius becomes a staggering 4 times larger, jumping all the way to 8,861 feet. Speed is a massive factor in how much sky you need to turn. Now hey, if you forget that 11.26 constant on test day, don't panic. There's a backup. You can use time and feet per second to find the circumference of your turn and simply do basic geometry to find the radius. First, convert your knots to feet per second by multiplying by 1.69. Next, take those feet per second and multiply by the total time it takes to do a 360-degree turn. That gives you the entire distance around the circle, the circumference. Then, just divide by pi to get the diameter and chop that in half to get your radius. Yeah, it's a few extra steps, but it gets you to the exact same result. Section 6. Ground Exam Final Review. Locking in knowledge. Let's wrap up this study session with a quick summary and a quick test of your aviation humor. All right, why do airplanes make terrible dancers? Because they have 2 left wings and can't coordinate their rate of turn. Hey, roan all you want, but staying relaxed is half the battle when taking these ground tests. Okay, back to business. Here is your high-yield checklist. Seriously, take a mental screenshot of this right now because these facts will definitely be on your test. Remember, we are always talking about true airspeed here. A higher airspeed always means a larger turn radius and a reduced rate of turn if you don't touch your ailerons. And finally, the golden rule. To keep the exact same rate of turn while flying faster, your bank angle absolutely must increase. You know, understanding your radius and rate isn't just about bubbling in the right answer on a multiple choice exam. It is about real-world survival. Picture this. You fly into a tight canyon and suddenly realize you need to execute a 180-degree turn to safely exit. Do you have the math to clear those walls? It's definitely something to think about. All right, hit that like button, subscribe for more PPL exam explainers, and as always, fly safe.